Hello and welcome to this little tutorial. You can already see here what we are going to build, but we will start from scratch and I will guide you through this. This is based on geometry scripting. It's a relatively new feature in Unreal that gives you the ability to manipulate meshes via Blueprint. I'm extremely excited about all the cool things we can do with geometry scripts, but without further ado, let's dive right in. I've created a fresh project using the first-person shooter template. After it's loaded, the first thing you want to do is to activate geometry scripts in the plugin settings. Reloading your project once again, and we are good to go. We start by creating a new blueprint. There's a new class called Generated Dynamic Mesh Actor. It's specially for geometry scripts. We call our blueprint BP_wall, and as soon as we open the blueprint, we see that there's a new component, the dynamic mesh component. This component renders your mesh, which is created and manipulated by geometry scripts. In general, you can also simply add this component to other blueprint classes and access the dynamic mesh. However, the generated dynamic mesh actor class that we are using here has a functionality that is otherwise not available. The event on rebuild generated mesh. This new event is basically your construction script for dynamic meshes. The target mesh you see here is your dynamic mesh that you can manipulate with geometry scripts. Currently, the dynamic mesh is still empty. We simply add a box here, connect the target mesh, compile, and let's have a look. Great, it works basically like a construction script. If we now go back into our script and promote the X and Z dimensions to variables, select, let's say, 400 as the default value for both. And then it's immediately updated in the editor as well. If we now make the variables public, then we can set the width and height in the editor as well. And we see that the dynamic mesh is updated and recalculated in the editor basically on the fly. This happens through the new event on rebuild generated mesh, which gives us the chance to create our own flexible tools for level design, for example. But that's another tutorial. Next, we create a node called apply PN tessellation and connect it again to our target mesh. This node basically performs a subdivision, as you might know from various 3D modeling applications. Let's choose 30 as the tessellation level. And in the wireframe, we now see that the mesh has new triangles. Since we are dealing with a pretty simple shape here that doesn't need too much detail, we can easily change the tessellation level to something lower. In general, it's a great way to add topology, especially if we want to apply, for example, displacement maps. Next, we are adding collision by creating the enable complex as simple collision node. We cannot connect our target mesh to the target pin here, but connect the dynamic mesh component directly. Last but not least, we save our target mesh as a variable. I'm just doing this for easier access later. So, looks great. We are done with this part. We have set up our wall, which we can adjust in the editor. We have added collision, and we also added the option for tessellation in case we need more details. Okay, Our goal is that when the player shoots at the wall, the dynamic mesh is manipulated at the point of impact. The first step is that we create an on-component hit event from the dynamic mesh component. We get a lot of nice data here. The most useful for us is the hit location. To test this quickly, we pull out a print string node and connect it to the hit location. Then we start a game and shoot at the wall. We see coordinates appear in the top left corner. Great, so that seems to work. Unfortunately, not really yet. We are running into two problems here. Firstly, there is an obvious problem because if we run into the wall with our first person character, this is also counted as a hit. If that's what we want, then cool, but we don't want this. The second problem is that the hit location is given to us as a world location. Since we want to perform certain operations on those points, it would be better for us if we could get the exact point on the wall, so to speak, in a local blueprint space. Fortunately, both problems can be solved easily. We first want to check which object hits the wall. Since we use the first person template, we know that there's a blueprint for the projectile. This is great because we can use it to cast to this specific blueprint and connect the object to the other actor pin here. We will test that in a moment, but first we want to look at the location problem. We get world transform output, but we want local transform. There's a very handy function for this called inverse transform location. T is the transform of an object that is used as a reference. Here we want the world transform of our dynamic mesh component, because this should be the basis for the hit location. Then we simply connect the hit location into the location pin of the node. Connect all of this to a print string again, and let's test. Great, we no longer get coordinates when we run into the wall with our character. Additionally, we see that we now have coordinates displayed that reflect the point of impact in local space. You might not recognize this immediately, but the numbers are way lower, so that worked too. The next step, we want to perform a Boolean operation at the hit location. For this, we create the node apply mesh Boolean. We connect our target mesh, that's the dynamic mesh we have created in the event above, to the target mesh pin of this node. We could also take this pin from the rebuild event, but to keep everything nice, tidy and clean, we are using the variable. We choose subtract as the operation because we want to shoot holes in the wall. We recognize, however, that in addition to the target mesh, we also need a tool mesh. The tool mesh is another mesh that in our case is to be subtracted from our wall. Now you might think that we could simply use a static mesh as a tool mesh.
It says no.
We also need a dynamic mesh here. Since we don't have any other dynamic meshes, we need to create one. Geometry scripts gives us the ability to create temporary dynamic meshes. The node for this is called allocate compute mesh. This temporary mesh is also still empty. We could append a primitive like we did in the beginning, but here we want to do something different. We use the node copy mesh from static mesh. This node does exactly what it says. It creates a dynamic mesh out of a static mesh. We want to take the projectile we are shooting, create a dynamic mesh out of this, and use it as our tool to be subtracted from our wall. We can already plug in the output to the tool mesh pin. Then we connect the output from the allocate compute mesh, the temporary mesh, and connect it with the dynamic mesh input here. Last but not least, we need a static mesh. We will promote this to a variable, call it ref mesh, compile it, and set it to our first person projectile that this specific template we are using here is using. Since compute meshes are very expensive and we basically create a new mesh with every hit of a projectile on the wall, there is another practical note here. Release all compute meshes. We simply insert this node after our Boolean operation, and it ensures that these temporary projectile meshes are deleted directly from the memory. Let's quickly test it. Okay, something is subtracted, so the Boolean operation works, but it's not where the hit location is, and it's actually quite huge. We want the sphere to be created exactly at the point where we hit the wall with the projectile. Fortunately, we have already converted the hit location and can now use it. We split the transform pin in the Boolean node and simply connect the return value of our inverse transform location with the transform location pin of our Boolean node. By that, every time we hit the wall at a specific point, we create a dynamic mesh copy of the projectile mesh at exactly this point and subtract it from our wall. We also want to scale the tool mesh since we have seen it's huge. The actual static mesh we are using is gigantic. In the blueprint for this projectile, they have also scaled it down. We also want to do this, and we could easily set a fixed value for this, like 0.15 should represent the project pretty well. But we want to add some more organic impacts of the projectile. Since we are already casting to the projectile blueprint, we can easily get the velocity of the projectile. Then we can get the vector length. So we get a number that represents the actual speed of the projectile. I know, because I have tested it before, that the max speed, so the max vector length, is 3000. With this knowledge, we can now divide the vector length by, let's say, 18,000. 3000 divided by 18,000 is 0.16. So the max speed creates a Boolean operation roughly similar to the size of the projectile. And if the projectile is slower than the max speed, the Boolean subtraction is slightly smaller. We split here the struct and connect this to all the inputs, and done. Quick summary. This is our calculation of the projectile speed to vary the size of the Boolean operation. This is the location we have recalculated from world into local space. And this part is the actual Boolean operation. We copied a static mesh to a dynamic mesh, used it as a tool to subtract parts of our wall we have created earlier. Let's see how it looks. You see these points of impact? If I let a projectile bounce so it loses speed, we see that the impact is smaller and it feels a little bit more organic here. I hope this simple demonstration could help you start tinkering around with geometry scripts by yourself. Yes, to do this at runtime is expensive for sure, especially Boolean operations or displacement maps. But I'm extremely excited about geometry scripting and how we can create more immersive worlds with such cool tools. And that's it. Thanks for watching.